Hello students, myself Prakyadi working as assistant professor in SJB Institute of Technology, Bangalore. Today I am going to explain the Nyquist plot. This is the simple example I taken for the Nyquist plot because this procedure you need to follow whenever the roots are not having s is equal to 0. That is nothing but if the roots are s is equal to 0 is there, you no need to follow this procedure. Okay. For this example, we don't have s is equal to 0. So this is the procedure you need to follow for this. Okay. So I will remove this thing. Okay. Next, you need to comment on stability. Okay. That is the question. Solve the problem, Nyquist plot, and comment on stability. First step you need to do is put s is equal to j omega. Wherever the s is there, you need to put j omega. So this is the step we need to follow. So g of j omega is equal to 50 divided by j omega plus 1 into j omega plus 2. Instead of s, we put j omega. Next step we need to follow is write the equation for magnitude and phase plot. Okay, the magnitude plot equation is, this is the equation. Okay, that is magnitude of g of j omega. For 50, this is 50 all divided by root of 1 square omega square, j omega square. Okay, j square is 1. So 1 plus omega square, and here 2 square is 4 plus omega square plus 4. This is the magnitude equation. And the phase angle equation, as we all know that 50, s is not there, 50 divided by s is not there, that is a constant value, so no need to take any angle value for that. So 1 divided by j omega plus 1 is nothing but j omega plus 1 in the denominator, so minus tan inverse omega by 1. Okay, minus tan inverse omega by 1. Next is 1 divided by j omega plus 2, that 2 in the denominator, so that is nothing but tan inverse omega by 2. Okay, so this is the same procedure to find the angular condition in your Bode plot what we discussed. Okay, next thing so serial number, omega, magnitude value, and g of j omega is equal to pi. Okay, so this is the magnitude value and this is the phase angle value. Put random values of omega. Okay, so I will put omega is equal to 0 in this equation number 1. You are going to get the magnitude value 25. If I put omega is equal to 0 in this phase angle, you are going to value 0 degree. So same thing, I taken 1, I taken 2, I taken 10, I taken 20, I taken 100. You can see here the magnitude will come to 0 in the future. Okay, so up to infinity if we solve, it will come near to the 0. You can see here 25, 16, 8, 0.5, 0.1, 0.05. 1 up to infinity we take random values of omega, it will reach definitely 0. Okay, so it start from 0 and it is going like this, minus 178 degree. At infinity, if you go like that, it will go 178, 179 point something like that. At infinity it will reach minus 180 degree. So finally, after having some nearer values of magnitude value 0 and nearer values to 180 degree, minus 180 degree, we can stop at this stage. Okay, next after calculating this value, we will go for the graph. Okay, first I will put and I will make imaginary axis, I will make real axis, and what is the maximum values of magnitude, that is 25. So up to 25 we need to take the real axis. And next we need to have angular condition. Okay, first angular condition is 0 degree, second angular condition is minus 78 degree, Next is minus 108, minus 163, minus 171, minus 178, minus 180 degree. So all the values I taken from 0. Okay. See here 72, 0, 90 degree, 108, 163, 171, 178 and 180 degree. Okay. I just put a line for that. At 0 degree, what is the magnitude value we have? 25. So this is the 0 degree line and 25 is the point we need to mark. So I mark 25 here. Next, for 72 degree, what is the magnitude value we need to mark? 16. Okay. I need to mark 16 means from here you take a scale and just mark the point where exactly the 16 is going to match the point. So that is the value. Next one, minus 108, this is 8. So minus 108, wherever the values of 8 in the negative real axis, just put a scale like that and you just mark the point over there. Like that you just mark the points of all this thing. So you just join wherever the line, dotted line which is there, and it is stops here. Then the mirror image we need to take here to reach here. Okay, and for this point minus 1 plus j0, minus 1 plus j0, that is nothing but this is the point, because here the minus 1 plus j0 will be there, the encircle values will be there here. It is not going to encircle this minus 1 plus j0. So that we need to identify. If we need to identify that, you are going to get the value p is equal to 0. How you got the value p is equal to 0? Number of poles g of s into h of s that are on the right of the s plane, because it is not encircling that minus 1 plus j0. Okay, so after that you are going to get p is equal to 0, z is equal to 0. So if you got this value, the system will be under stable condition. Okay, so this is the very important problem in any of the university exams. And next video I will explain if you got s in this position, that is nothing but s is equal to 0. If you got that, how to solve that, that is a different procedure we need to follow. Okay, thank you students.